Hello, I'm Papia. In this problem, we have to approximate the value of this definite integral using the series of arctan x, which is right here, and using the fact that Rn is less equal to 0.001. So we use the series of arctangent x, and we have to figure out what is the series of this function, arctangent of x squared divided by x, and then we have to integrate by integrating the series. So what is arctangent of x squared? Using the property of series, you know that if you have the series for arctangent of x, you just replace x by x squared, and you will get the series for arctangent of x squared. So this series will be -1 to the n x squared to the power 2n plus 1 divided by 2n plus 1. All right. Next, we have to divide this function by x. Okay, so let's do that. So arctangent of x squared divided by x, and that will be equal to, you write down the term inside the series and divide by x. So -1 to the n. You can simplify this x term. See, the 2 will be multiplied to 2n plus 1 in the power, so it will become 4n plus 2 divided by 2n plus 1, and you're dividing by x. So since we have common base, both numerator and denominator, and this x has a power 1, you can just subtract their exponents. So the series simplified form will be -1 to the n x to the power 4n plus 2 minus 1, so 4n plus 1 divided by 2n plus 1. So this is the infinite series for the function arctangent x squared divided by x. And we have to integrate this function, which means we will integrate the series. Okay. Let's just do the indefinite integral first. So the series will be integral of the term here, but notice that we're only integrating with respect to x. So all the terms that don't have x in it is just a constant. So you can pull out -1 to the n over 2n plus 1 and just integrate the term that has x in it, x to the 4n plus 1 dx. And of course, I should write plus c, but notice that it will be a definite integral in the end, so I really can ignore it right now. Okay, so let's continue. So the integral will give you this new series, -1 to the power n divided by 2n plus 1, and then you're integrating x to the 4n plus 1, just use the power rule, so x to the power 4n plus 2 divided by 4n plus 2. Therefore, what is the definite integral 0 to 1/2 arctangent of x squared divided by x dx? That is equal to the series -1 to the n divided by 2n plus 1 times 4n plus 2, and in the top you plug in 0 and 1/2 for x. So we'll have x to the 4n plus 2 and plug in 0 to 1/2. Okay, let's see what we get. when you plug in 1/2, you have 1/2 to the power 4n plus 2. Minus, when you plug in 0, you will just have 0. So you can ignore the 0, and we can just plug in 1/2. And keep everything else as it is. I want to write one more step and simplify this a little bit so that we can finish the problem and find the approximate value easily. So notice that in the numerator, we will only have -1 to the power n. And this 1/2, the 2 actually belongs in the denominator. And 1 to the power 4n plus 2 is just 1. So you don't have to write anything else in the numerator. Everything will be in the denominator. So we will have 2 to the power 4n plus 2. We will have a 2n plus 1 and 4n plus 2. So this is the series corresponding to the definite integral of arctan of x squared over x from 0 to 1/2. All right, to finish this problem, we have to, remember, we have to approximate the value of this definite integral. And we have to use this fact that Rn, that's the remainder that we get from the alternating series, and it also gives us the error. The error is less equal to 0.001. So recall what we know about Rn. Recall that Rn, absolute value, is less equal to an plus 1. And what is an plus 1? So if you have an alternating series, which we have right here, an is the positive part of that series. So we have this fact that absolute Rn is less equal to the next term, an plus 1. Now, we are given that we need to have Rn to be less than 0.001, so we want this to be less than 0.001. So for which n do we get an plus 1 is less than 0.001? In order to figure that, we first have to figure out what is an plus 1. Okay, so we want n so that an plus 1 is less equal to 0.001. Okay, now, like I said, an is right here. This part is an with a 1 here, right? So how do we figure out the next term? Just plug in n plus 1 wherever you see an n. That's how. Okay, so we have 1 over 2 to the power 4 times, plug in n plus 1 plus 2. Then we have this factor 2 times, instead of n, write n plus 1 plus 1. And we have another factor 4 times, again instead of n, write n plus 1 plus 2. This entire term should be less equal to 0.001. Figure out for which n this will happen. If you want to simplify a little bit, you have 2 to the power, so this is 4n plus 4 plus 2, so plus 6, times you have 2n plus 2 plus 1, so 2n plus 3, and 4n plus 4 plus 2, 6. That has to be less than or equal to 0.001. Now at this point, it's not easy to directly solve for n. What you have to do is you have to use a trial and error method. So you just plug in some n values in this term and then figure out when you will reach less than 0.001. Now I have done that, and I have figured out that you can get this quantity to be less than 0.001 for n equals 0. What does that mean? N equals 0 will give you this. So if n is 0, That means, look here, n is 0. So this is a 0 plus 1. So the term a1 will be less than equal to 0.001. Therefore, how to approximate our integral? You can just approximate it by using the very first term in the series. And the very first term is a0. See, it starts at n equals 0. So this means we can approximate our integral just finding what the term a0 is. Okay, let's see what a0 is. Plug in n equals 0 in this entire term. So the negative 1 to the n becomes just positive 1. So for n equals 0, we get, let's figure it out from here. So we have 1 in the top, the bottom, plug in n equals 0, so we get 2 square. We get 4. N equals 0, you will just get 1 from here. N equals 0, you will get 2. So this is 1/8. And 1/8 is 0.125. So our approximate value is 0.125. That completes the problem. Thank you.